And thank you all for who managed to connect at this point in time. We're expecting more numbers to join. This training will mainly be led by our colleague, Eris, who is an expert in resilience. And then for this webinar, we have participants from South Africa, from Mozambique, from Philippines, and a few colleagues from Zimbabwe who are also joining us. But before we start, let me give a brief background and context of why we are here and for this event. So the IFC has developed the Building Resilience Index, a web-based hazard mapping and resilience assessment framework for the building sector. So the BRI offers valuable insights for developers, for policymakers, investors to make informed decisions. So the question will be, why BRI and why we are here today? As you all know, the Southern African region is highly vulnerable to natural disasters. These include floods. I think floods are quite pronounced in this region of Africa, cyclones, landslides. In 2019, for those in Africa, we are all aware of the Cyclone Idai and Cyclone Kenneth, which caused havoc in Mozambique, Zimbabwe, South Africa, and Malawi. Yeah, the whole Southern African region. So the increasing frequency and intensity of these events due to climate change underscore the urgent need for resilient infrastructure. In economic terms, flooding is the most significant natural disaster, with Cyclone Idai in 2019 causing damages of up to about 3 billion in Mozambique, around 274 million, that is in US dollars, 274 million in Zimbabwe, and around 50 million in South Africa. And infrastructure damage accounts for a substantial portion of these losses, with thousands of homes, schools, and hospitals being affected. In KwaZulu-Natal in South Africa and Western Cape, flood events have become a very common phenomenon, causing serious damage to infrastructure and displacement of communities. Research has shown that since 2007, an estimated 1 million people were affected directly or indirectly by river flooding in Southern Africa. So what are the benefits of BRI? The BRI helps vulnerabilities in existing buildings and provides guidelines for enhancing resilience. It supports the development of a safer, more resilient buildings that can withstand natural disasters, reducing economic losses and saving lives. By assessing vulnerability of buildings with BRI, project owners can attract more investments in resilient infrastructure, fostering economic growth and stability. So the successful implementation of this program of the BRI requires that we collaborate with stakeholders and the professionals. The professionals who we have invited today are a key stakeholder in the building sector. And that is the reason why we are here today for this event. We want to thank you all for showing interest in the BRI too, and to enroll as our first batch of BRI. Is in South Africa is the first batch, and I know our colleagues in Mozambique and Philippines. We thank you for the continued endeavor to make the BRI program a success. I will let my colleague Eris introduce himself further and go ahead with the training. And over to you, Eris.
Thank you, Petmore, for those introductory remarks. I'm Aris Papadopoulos. I'm an engineer by training. I spent most of my career in the construction industry. I've been through many hazard events, earthquakes in my paternal homeland of Greece, and hurricanes, cyclones, as they're known elsewhere, and floods in the southern part of the US, and even fires. I also was in the World Trade Center in 9/11, and that kind of left an impact and fueled my interest in resilience. I helped the UN Office for Disaster Risk Reduction create a private sector network, which is now known as ARISE, and served as its first chair, and helped in the Sendai framework for DRR that was signed in 2015 in Japan by 187, I think, countries. And I was honored to be invited by IFC to help develop the Building Resilience Index and lead a global expert team. So thank you for taking this afternoon time. This is a training for verifiers, and we'll begin kind of through a list of the topics here that we'll be covering. We'll be covering 3 topics. First is an overview of what BRI is and isn't. Second is discussing the role of the BRI verifier, a very important role, as you will see. And third, we will go through a case example of verifying a building, and a building was suggested to me in Durban, South Africa, that we will go step by step to kind of address what questions the verifier should be asking and what information they need to be verifying in this particular example, going through all the steps along the way. So this will be, we'll try to cover today. I'll pause between these, the first and the second topic here, to answer questions. So you don't have to wait to the very end. You can post your questions for each section, and we'll take time to answer them before going to the next section. And of course, at the end, we'll have another opportunity to answer questions. So this is the outline. Thank you again for joining today. Let's start with some definitions here. First of all, what makes a building resilient? There are 2 components to that. One is what we call physical integrity, the ability of the building to resist the hazard in that location. And the second is operational continuity, assuming that the building survives physically. Can it function? Can it operate as it did prior to the hazard? So BRI incorporates both of these dimensions into its rating, the physical integrity and the operational continuity. What makes a building resilient? A building needs obviously to identify the risks that are applicable for its location. Second, to design and construct the resilient measures that are needed to address those risks. And third, as we know, a building is like a human body, needs to be properly maintained, so diligent maintenance. BRI focuses on the first 2, the identification of the site risks and the design and construction of the building, rather than the third. But we do ask verifiers when they visit existing buildings to spot check whether maintenance, there are any signs of deterioration and poor maintenance. And I will highlight some of those later in the presentation. So what is BRI in a short sentence here? BRI essentially is a verified self-assessment. The building is assessing itself, but that assessment is verified by 2 experienced and certified building professionals who are certified by IFC, and you are obviously all candidates for that. So the verification is the quality control for the self-assessment, and it is a rating. It is not a certification. A rating for any building type It can be a small building, a house, a large hospital, a school, government building, any type of building, warehouse. BRI is not for infrastructure such as streets, highways, dams, bridges, piers. In an airport, for example, you can rate the buildings, you cannot rate the runway. In a port, you cannot rate the piers, but you can rate the warehouses and the buildings. And basically what we are rating are the hazard mitigation measures. We are not rating the hazards, we are rating the building's mitigation measures that it has to defend itself from those hazards. So this is a short sentence of what BRI is, and obviously we'll be discussing all the components of that. An important thing for BRI was it has to be both robust, meaning it has to be conservative, because nature will test the resilience of the buildings. The same strictness does not necessarily apply to green ratings, where nature will not is not a severe tester. There's no objective natural test for the greenness of a building, but for resilience, nature at some point will test and is a severe, strict tester. But at the same time, a BRI has to be easy to apply. I like to say it cannot be a, let's say, master's thesis to make for every building. Therefore, BRI aims to be a standardized assessment. You can do customized assessments that end up being essentially mini theses, but those are more expensive and cannot be applied at scale. So to be a robust standardized assessment, BRI is by its nature conservative, and we'll be discussing the conservative dimensions of BRI. As was mentioned before, BRI, the Building Resilience Index, is a innovation, a product of the International Finance Corp, a part of the World Bank that lends to the private sector in developing countries, and basically aimed to complement the very successful EDGE application for rating the efficient energy efficiency and environmental footprint of buildings. IFC very wisely realized that it needed a separate metric for resilience, that it could not build resilience into its green metric, EDGE. It needed to have a separate metric. And for me, that was very important, that realization, so that if a building is to be truly sustainable, it needs to rate high, both in EDGE and in BRI. So what is the relation of BRI to local codes? This is often a question. A lot of countries and jurisdictions have building regulations. It's very common. BRI does not aim to replace local codes, but to supplement local codes. And in general, BRI is stricter than most local codes. In fact, the buildings that are rated must already be compliant to their local codes at the time they were built, obviously. So it's a prerequisite. The local code is a prerequisite, but BRI looks and goes above that. So most codes have been developed with life safety as their primary goal. In other words, to give occupants enough time to escape and leave the building. Not necessarily to let the building survive the hazard. So the occupants, whether that's a house or an office or other building, may be able to evacuate, but they may not have a building to come back to. So BRI aims to go above that to help assure that the building itself survives and people can actually return to the building. Therefore, BRI is more conservative than local codes. And often people will ask, well, I met the local codes. Why am I not rated very high? And this here explains why, because the codes are set at a lower level. I like to say that obviously codes evolve with time, especially after major disasters. Codes are relooked at. And BRI essentially is pointing to where future codes should be. So if you build to a high BRI standard, you'll probably be addressing not only today's codes or yesterday's codes if it was an older building, but tomorrow's codes, the codes 5, 10, or more years from now. And in summary, the focus is different. Codes focus, as we said, on health and on safety, but also codes are an economic compromise. There's a lot of a negotiation on the economics, and obviously, some of the other aspects are sacrificed in the interest of economics. So codes focus on those two. EDGE focuses on the environmental footprint, and BRI focuses on the resilience. So if you have all of these, obviously you're a very sustainable building. There are 4 ratings for the BRI evaluation. At the very top is what we call global best practices. Essentially, our global expert team of people who had experienced not just theoretical, but practical experience with buildings all around the world and had seen disasters, collected what we call the best of the best, taking from different countries what were considered the best practices for mitigating particular risks. For example, for seismic, we turn to Japan, that for many decades has been applying the best practices, and some of those practices, in fact, are starting to spread to other parts of the world. For example, the severe earthquake in Turkey a few years ago, the hospitals that survived had some of these Japan, let's say, based practices of seismic base isolation. So this is the best of the best. And below that, kind of at a second step level, are what we call strong practices. And these will also be above the codes of any one country. Very few buildings will be at these 2 levels. So most buildings today are going to be at the B or the NR level. B being considered the minimal practices required for a building to be called resilient, and then NR essentially being weak practices that we know will be subject to destruction when the hazard occurs, and also anything unpermitted that was done without a code permission, also unplanned development, as we see in many developing countries, would be in this NR category. So the goal of the initial goal, let's say, of BRI is to make sure that we stop building NRs. We should not be building any new NRs. Let's build at least to the B level. B should be considered a success. And then, A and AA maybe, something higher than that. For example, a hospital may not be happy just to be at a B level, may be aiming for an A level, but a house may be happy, or an office to be at that B level. Again, it's up to the developer to choose how much they are wanting to invest to go to the highest level, but do not consider B to be a failure. B is a success. Not being an NR is a success, and being an NR is a failure. So that's the initial goal, to avoid building NRs, and as much as possible to retrofit existing NRs into Bs. That is sometimes possible, but sometimes it is not possible. It's unpractical or uneconomic to retrofit an existing building to the measures that are needed to bring it to the B level. And the only way to practically accomplish that is to demolish it and build something new from the start. But perhaps some of the buildings can be retrofitted into Bs in the future. So these are the 4 levels. And I'd say today that 90% of buildings are going to be at the B and NR level, even in developed countries. And less than 10% of the buildings will be A and AA's. But hopefully in the future, we'll be moving more buildings into higher levels. And on top of that, as we mentioned initially, the second dimension of resilience is operational continuity. There are a list of measures that we'll be showing that today, if you meet 3 out of those 10 measures, you can add a plus designation to the letter rating. So you can be a B plus. So that's the overall rating system. So basically, it's a rating. It's not a certification, and that obviously has to deal with liability, which we'll discuss. But it's a relative rating, meaning that AA we know is better than A, which is better than B, which is better than NR. At this point, we don't know exactly how much better. We'll be obviously getting data from buildings over time, and getting that information. But we know definitely that one is better than the other. So I call it a relative rating. And the reason it is a rating and not a certification is that the responsibility and liability remain with the building owner and their professional team. IFC is providing a tool for self-rating that the verifiers are verifying the answers, but is not assuming any liability or responsibility. That remains with the building owner and their team. So BRI has three components, and it is free. It is open source. It's fully transparent. You can see exactly what is inside BRI. It's not a black box that you just put data in and somehow miraculously get an answer. You know exactly why you got the answer you got, what measures you're missing, what measures you have, and what you can need to do to improve yourself. And it has three major kind of components to it. The first being the hazard knowledge, with the aim being that when a building address or its geographic coordinates are input, that BRI tells you what the applicable hazards are for that location. Now, this hazard knowledge is still ongoing in the application. It is not complete, and therefore we do ask both the assessors and the verifiers to check themselves from their own local knowledge if those hazards have been completely identified. So the knowledge is still a work in progress here. The second component of BRI is the mitigation knowledge, and that has been completed. Basically, we have the global best practices, we have the practices for the levels of A and B. So that mitigation knowledge is incorporated into the application. So once a hazard is identified as applicable to that location, to that building, BRI will produce a list of mitigation measures that are important for addressing that hazard. And what the building has to do is essentially answer whether it has or does not have each of those mitigation measures. So that's what we call the building information. That's what the assessors are asked to do. And obviously their answers have to be verified by the two certified verifiers. So the building can answer, yes, I have this measure, but the verifier has to check, does the building indeed have that measure? How do I know? Let me look at the documentation. Let me visit the building. Let me verify that the building has what it says it has. So that is the quality control. So these are the three main components of BRI. As I said, it's a free tool. IFC does not charge for it. The only cost to the building is the time of the assessors and the verifiers that the building will be paying directly. I like to put this kind of example up here of two identical buildings. They were identically designed and built, and in fact, they both rated very high on the green certification, high EDGE rating. But when we looked at them from the BRI perspective, one on the left turned out to be an A, and the one on the right turned out to be an NR. Two identical buildings. So, how is that possible? The one is an A and the other is an NR. And the answer to that is that we may have identical buildings, but they are in different locations. The location on the left has relatively mild hazards of downburst, subsidence, and urban flooding that its design and construction has addressed. But if you use that same design and construction for a building that will experience typhoons, earthquakes, and flash flooding, that building will be subject to damage and perhaps destruction. So, BRI and resilience is very location specific, and the hazards of the location obviously affect the design and construction of the building, something that is not as pronounced in green ratings. So, that's what complicates resilience ratings to some extent. So I also like to ask, who is the customer? And most people in the building, professions and industry will say, well, the customer is the owner, or the developer, or the people who are leasing the building. And I like to reply to that, true, but the customer is also nature, and nature is a much more demanding customer. And if nature is not satisfied, then nobody else will in the future be satisfied, because nature will take its toll on the building. So when you're talking to developers and owners and so forth, and they're pleading with you why they can't get a higher rating, keep in mind that your customer is also nature, and we need to satisfy nature, and BRI obviously is focused on that particular goal. So we mentioned the hazards are site specific. BRI organizes the hazards into 4 major categories: wind, water, fire, and geoseismic. And within each of those categories are specific hazard types. The top row here is what we call in BRI default hazards. In other words, no matter where the building is in the world, it needs to be addressing those 4 hazards of downbursts, urban flooding, even deserts experience floods from time to time, local fires that can originate from inside or outside the building, and ground subsidence. And then depending on the location of the building, it can have many or several of the other types of hazards that are shown below. I highlighted here, since our case example is in South Africa, what I felt in red is applicable. Somebody said they cannot see the presentation. Hello, can you see it? Hello? Okay.
We can see it from the side, but it seems there are some few who are having challenges.
Okay. Well, we will also
share the recording after this, so even if you can't see it right now, this will come up in a write-up email. Thank you.
Okay. All right. So as I was saying, since our in the third part of the discussion today, our case example is from South Africa. I highlighted in red what I observe being the hazards in various parts of South Africa. As you can see, there are quite a few hazards, as you mentioned earlier. Petmore, South Africa, is affected by many hazards. So, definitely you'll see a lot of these in buildings that you are rating. So as I mentioned, the BRI can be used for any building, new or existing. In fact, we encourage as much as possible for buildings to assess themselves in the design or even site selection phase. The rating at that point will be a preliminary rating, but it can help them address mitigation measures in a more practical and cost-effective way than after a building is constructed. It costs much more to change a building after it's built than to change the location or the design of the building before it's built. So for buildings in design or construction, the BRI rating that will be done will be a tentative one, and then a final rating will be given following post-construction verification. So BRI can provide valuable input into the design and even site selection process. We said that BRI is conservative. One of its conservative kind of aspects is what we call the weakest link principle, meaning that nature will eventually find the weakest part of the building and harm it, damage it, or even destroy it there. Therefore, BRI assigns a rating for each hazard category, but the overall rating for the building will be the lowest of the four. In the example, hypothetical example on the left, because the building has a B rating in geoseismic, it overall will rate a B, and on the right, if it has an NR in fire, it will overall be an NR. But BRI, being open and transparent, will tell the building what it is missing. For example, in geoseismic on the left, what measures it is missing to become an A. And if the building can address those measures and raise its B level to an A, then it will be an overall A. So BRI essentially focuses the building on its weakest link and says, you know, pay attention to your weakest link. If you can improve that, you can raise your overall rating, which is, you know, how things actually work. So that is a conservative aspect. We're not averaging, we're taking, you know, the lowest and saying that's your weakest link, that's what you need to focus on. Now, I'll address some, you know, general statistics on the mitigation measures. Here broken down into the four hazard categories. Some of them are related to the location of the building. Most of them are related to the structural, the design and construction of the building itself. And a few are related to inspections that occurred during the construction of the building, both by, let's say, required by code and also in addition to code. So we have kind of the number of measures here for each one of these. You see in water, we have, 3 location-specific measures because water is so location, the water hazards are so location-specific. For example, if you're building in a floodplain or a former marshland, definitely your location will affect the rating. Fire, if you're building near a wildland location, and obviously geoseismic is very location-specific. If you're next to a landslide-prone hill area, etc. But most of the measures refer to design and construction aspects, and we will see those in the case examples, in the example, and some of them refer to inspections that are done. Obviously, this is the grand total of measures. For any specific location, it'll be a subset of these, depending on the number of hazards and depending on the rating level that the building aims to achieve. So the higher the rating level, the more mitigation measures it needs to satisfy, and the number goes up exponentially, not just linearly. So it's much more demanding to achieve the A and the AA level because the number of measures triples perhaps. So this is an overall summary. There are about a little over 60 measures here in total, but as I said, for any particular building, it will be a subset of these. Now, looking at the measures in relation to the rating levels for cyclone-prone locations, the AA requires a reinforced concrete construction. A can be any material, but rated above 290 kilometers an hour. The B level for cyclone is 200 kilometers an hour, and anything that does not rate above that, above 200, is considered an NR. This is for non-tsunami locations that are subject to, let's say, flash floods or river lake flooding. To not be an NR, you need to be at least 3 meters above the local water, whether that's the sea or it's the river level or a lake or even the bottom of a dry creek. And obviously those criteria become higher as you go into the A and AA. And for tsunamis, they're even much higher. They're like 5, 10, and 15 tsunami risk locations. For fire rating, and this is just a sampling, there are other additional measures obviously in the list, relating to the key elements, there are fire rating criteria for the components. Anything less than half an hour is considered an R. Above an hour is a, and above 3 hours is a double A. And for earthquakes, the global best practice, I mentioned the example for the Turkey hospitals, seismic base isolation is required for buildings above 4 stories and above, having a well-braced structure for an A rating, and having reinforced walls and no soft stories for a B, and when lacking the above, will put the building in the NR category. So let's move on to the operational continuity measures. There are a list of 10 measures, and all of this is explained in detail in the user guide that you should review, if you haven't already, definitely before the verifier exam, because they're explained in details. There are also schematics that show you, what we're talking about. But there's a list here of 10 operational continuity measures, including green certification. If the building has a EDGE rating or equivalent, it satisfies one of those. If it has on-site renewable power that can satisfy at least 12 hours of daily demand, it satisfies another one. So, if it meets, and I think BRI is generous at this point, if it meets at least 3 out of these 10 measures for operational continuity, it can add the plus designation to its letter rating. These include backup communication, even having a common area for emergency supplies is one of them, and for larger, let's say, buildings, having a disaster protocol and designed parties, designated trained parties. So summarizing BRI's terms, it's free and open source, as we said. The rating itself is valid for 10 years or earlier if a major event occurs, and I'll explain what major event is on the next exhibit. So up to 10 years. And as we mentioned before, it is a rating, not a certification, and it needs to be verified by 2 registered building professionals on site. We do not accept remote verifications. You can't do this from your office and your computer. You have to visit the building as a verifier at least once and walk through the building. And we know as building professionals that seeing is knowing. You need to see the buildings that you're talking about. So these are the kind of basic terms here. What is a major event? It could be damage from a hazard that can trigger an earlier need to re-verify. A major building renovation. I'm not talking about cosmetic renovation like repainting, redecorating, but something that structurally changes the building. Could be adding an accessory space to the building, removing something from the building structure, changing it, etc. And a major change in use. We've seen buildings that were built originally, let's say, for residential, multi-story residential. They're converted to some industrial use, and they can be, impacted from that. So if there's a major use, the building has to be re-rated. So let me pause at this point to address any questions that you may have on the material so far. And maybe you, because I can't read the, if there are any questions written, maybe Petmore, you can help me by sharing the questions if they're written.
Yes, Eris, for now, I don't see any questions except participants who are having some bit of challenges. I'm assuming that most of them have been addressed. So I don't see any questions yet, but I'm sure we will be seeing questions before the end of the session.
Okay,
Yes,
I think somebody posted something. Go ahead.
Yes, this is Bania Aris. To the participants, you referred to the user guide. This is a document that is available public online. I shared the link so that can solve also many of your questions.
Yes, and Eris, I think I see one question which says, are there any prerequisites to achieve ratings such as in LEED?
Are there any prerequisites to achieve ratings such as LEED?
In LEED, I wish if the participant could explain what LEED refers to.
I know what LEED is, a green rating similar to EDGE that originated in the US and is used in some other parts of the world. So this LEED does not, I mean, LEED is trying to get resilience into it, but I believe LEED has decided to take the approach of trying to incorporate resilience into its LEED rating, which to me is not the right way to do it. So I basically have this disagreement with LEED on the way they are approaching resilience. I'm not sure if that answers the question.
Hopefully the participant is answered. If there are any questions, I will pose them to you, Eris.
Okay.
Thank you.
We're ready. Let's move on to the second part. Are there any, I see another question popped up. Are there any mandatory, can you read the question? Is there another question?
Hi, Aris.
Yeah. Can you read the question, please?
Actually, I'm speaking because we are together in the room. Aris, can you hear us?
Yes, go ahead.
Okay, it's Sylvia here. She's in the room and she's going to comment. Please, Sylvia. First of all, thank you for the presentation. I just have a question because I'm an entrepreneur on the civil construction industry and we work a lot with innovation, alternative materials, and the idea is to use natural resources to either to reach the conventional method resilience or even above. So I didn't see you commenting on how this is addressed on BRI, if it's not really the normal concrete beams and things like that. For instance, interlocking blocks that normally provide even better resilience than conventional blocks, at least in Mozambique. They are above 5 MPAs. They have been tested in situations of, let's say, simulation of cyclones. They can reach above 6 in the Richter scale without collapsing. So those sort of things, should they fall under the local codes before we go to the BRI, or we can directly use this tool to reflect a better index given those alternative, let's say, materials or techniques? Don't know if I made myself clear.
Yes, I think you have, and thank you for the question. It's a good question. Let me answer it in two parts here. One is that the building must have satisfied the local code. So if the local code accepts, has already accepted the material and it meets, the code, that's a first, let's say, check mark. If it has not yet accepted the material, then BRI obviously cannot rate the building. So the first level is that the local code has to have accepted the material. Now, assuming the local code has accepted the material or the technique or combination, BRI's rating levels, particularly the B, the basic level, and the A, are performance specific. In other words, BRI talks about miles per hour requirements, talks about how many meters the building needs to be above the local water, talks about the fire rating in hours, let's say. So, a material that has been tested, that is, the specifications show that it does meet, particular levels, will be acceptable to BRI. The AA rating sometimes is much more prescriptive, but very few buildings will be rated at that level. So for the basic B level and even the A level, performance, criteria are what BRI uses. So, any local solutions or innovative solutions that the code accepts, can be used as long as they meet the performance criteria. I hope I've answered your question.
Yes, it does. Just curious about what were the examples of buildings that are on top ranking for BRA.
Examples of buildings. Well, I haven't really seen rated a building now that rated overall at the AA. I've seen buildings that have rated on particular hazards at the AA. That have the seismic base isolation that BRI requires for a 4+ building, or have wind design standards that meet the criteria for the AA. But I have not yet seen a building that has met that we've looked at that has met a AA across all hazards. But do not, again, I urge that you do not start with a mindset that I need an A or AA. You need a B. A B is a success. So achieving a B is very important at this stage. So I would focus, can the building at least meet the B level? And if it has some A elements to it, does it have enough to say, well, I can invest in the elements that are missing to get it to the A level, which may be possible in a building that's being designed, will be much more difficult in a building that already has been built.
Just one last comment. If you thought, or there are some examples of how can you help the clients, the people, to perceive more value by putting more effort to this, like let's say real estate owners and people that really own projects. So when they get certain type of, let's say, B or even more, what are the examples of how this can be communicated or be perceived as additional value than just having a bunch of engineers visiting and filling reports?
Yeah, again, that's a good question, and it's the topic of another presentation to discuss kind of the selling of BRI. This webinar today presentation is focused on training verifiers. So it's we're focused on the technical aspects of the verification, but we've done presentations. We have presentations that talk about what are the benefits today and the potential future benefits of having a BRI rating. So it's a good question, but it's not one that we're going to get into today in today's subject.
Thank you.
I also have one. Sorry. I don't know if I should ask this now or maybe later on, but this is a question regarding the table that is present on the user guide version 1.3, and I believe on the new version 1.5. I don't know the name of the table at this moment, but it's a table that presents what are the future costs that you will have on a building if you apply or don't apply the BRI mitigations. There was a 4:1, 11:1, a 16:1. Do you know what table I'm referring to?
This is from a study that was done in the U.S. by the National Institute for Building Science, NIBS, that looked at the cost benefit of resilience, and it's provided there just for informational purposes. It's not really linked to the rating system that we have, but obviously the studies that have been done have shown that if you invest in resilience, the return is multiple time the investment, but that varies depending on the type of building, the location of the building, etc. But so it's there for informational purposes, and it's a study that was done by NIBS.
And sorry, what I did not understand on the table was exactly what do the fractions mean? 11:1, 4:1. It means you return 4 times the cost of the building.
Yes. Yeah, if you invest 1 unit, let's say $1 or euro or whatever currency you're using, that in the future, you'll get 4 times that, and that's a discounted number. It's not just the future value, it's a discounted number, and incorporated benefits both to the owner and to the community. And I think that particular study even included health benefits.
Okay, interesting. So it's not relevant to the discussion of today. Okay, just to understand.
No,
Thank you.
no. I mean, there's a lot of material in the guide that's informational, background information. I like to say focus on the mitigation measure discussions and the details there. But there's a lot of contextual information there too for everyone.
Aris, let's move on. I'm conscious about time. We can also write down all the questions and answer separately. Thank you, Aris.
Excellent. Yeah. Okay, let's move on the role of the verifier. The role of the verifier is very important because without the verifier, we cannot have a correct rating. The verifier, first of all, if they see any hazard inconsistencies that they are aware on from their background knowledge, they should question them. They should ask IFC, this hazard is appearing. I know it's not there, can you double check? Or I know this hazard exists, but BRI is not producing it. As I've mentioned before, the hazard knowledge is not complete for every location at this point. So there are gaps in the hazard information. So questioning any hazard inconsistencies. Second, verifying that the mitigation measures that the applicant selected are correct. And these are either yes or no or not applicable. And if the assessor is saying not applicable, is the not applicable correct, because sometimes people will put not applicable, but there's got to be a reason, and that reason has to be verified. And finally, the fourth, which I mentioned earlier, that's why we require on-site also, visits, is to identify any visible building deterioration. That's that third component that BRI doesn't directly rate, but we'd like the verifiers to at least identify anything they see when they visit the building. They're not doing a detailed maintenance inspection, but I'll mention a couple things that are kind of telltale signs of building deterioration. Here, there are a couple pages here of maybe I call fine print verifier conditions, and I'll read through these. That the verifiers must be building professionals registered in the location's jurisdiction, whether that's the country or the region of the country where their license is issued, and that they have a valid professional certificate or license, and that has to be uploaded into the BRI application. One of the two verifiers should be a registered civil or structural engineer. The other can be civil, mechanical, electrical, architect, environmental, or any other relevant building professional, again, registered in that jurisdiction. And both should have a minimum of 10 years experience. And they should attend the training that you're attending now, pass a test that IFC administers, and receive their verifier certificate. And there may be update courses required from time to time. Continuing the conditions, the verifier should retain their own files of all the documents that they relied on to perform the verification, with perhaps giving a copy to the building owner, so the owner has a copy of what they accumulated. We're not asking for any documents to be provided to IFC unless we explicitly request from the IFC side that they be provided. The verifiers have no contractual relation to IFC and are selected and engaged by the building or the project. Verifiers retain full responsibility for the correctness of the verifications they conduct. And IFC reserves the right to withdraw a verifier certificate if discrepancies are found in a verifier's work at time to time and in sole discretion. And IFC may from time to time audit building ratings, particularly after events, to see, this building was damaged severely. It had a B rating. Why did it happen? Was there any discrepancy in the verification? The things that BRI cannot easily identify include the design and construction errors and omissions. There may be errors in the design of the building, omissions in the construction. These are things that BRI cannot identify, and oftentimes, they're only identified after the fact, after a damage occurs. BRI cannot identify defective materials. If the materials used were not, quality, did not meet the quality standards that they claimed they had. Poor workmanship in the construction cannot be identified, and poor maintenance most of the time cannot be identified, and any inappropriate change of use that is not reported, cannot be seen at a later point in time unless it is reported. So when you visit a site as a verifier, especially looking at an older building, some of the things to look at is subsidence. Is the building kind of tilting in one direction or another? I like to carry with me a small ruler with a level in it, and sometimes when something looks funny to me, I just put the level ruler against the wall or a part of the building and see, is it level? That's a first sign of subsidence. Second is cracks in the building, especially older buildings. If you witness severe cracks, corrosion can occur inside those cracks with reinforcement or other corrosive materials, corrodable materials, and water stains. If you see visible water stains on the walls, on the ceilings, and parts of the building, that's a telltale sign that water somehow is getting inside the building. And what we ask the verifiers to do is when they see some of those, basically to record them, to note that, and even take pictures and say, this is what and if the verifier considers them serious, they should notify the building, let's say, representative, and say, we see these, this maintenance, deterioration, and so forth, and perhaps this is something the building will need to address before the verification is concluded. So I would ask the building, okay, what's your plan to correct these? And I'll wait until you correct them before I come back and complete my verification. So, this is why a site visit is important. And obviously, we're not looking for a complete inspection of every part of the building. But as you're walking through a building, especially an older one, keep an eye out for any of these signs. Frequently asked questions. BRI users can set a target rating based on building criticality, meaning that BRI doesn't have different requirements for different buildings, but a building that is more critical should be aiming for something higher than a B. A hospital, for example, should not be just satisfied for a B. A house may be satisfied at a B level, but a hospital should be aiming perhaps for an A level, or a critical government building for that matter that will be important during a disaster event. So the user can set the target rating and say, this building is critical. I need to invest more in mitigation measures to make sure that it survives and is operable. And I need to aim for, therefore, the A rating for this building rather than just the B rating. And as I mentioned before, BRI's mitigation measures are more performance focused, particularly at the B and A level, than prescriptive. So BRI allows for local solutions that are accepted by the local codes in meeting those performance standards, whether a building has to be elevated a certain height, or resistant to winds, or resistant to fire, etc. And BRI relies essentially for its rating on the building's mitigation measures rather than public defensive infrastructure outside of the building. Example, there may be a dike or a seawall or something outside of the property that may be at a certain height, and the building may say, look, I have that defense outside my property, and therefore I meet the measure. Well, BRI doesn't work that way. BRI assumes that at some point that public defense will fail, whether it's under-designed, or it's not properly maintained, or it's not properly operated. And BRI basically asks, what's going to happen to the building if that public defense fails? Do you have enough mitigation for the building to survive? Therefore, BRI doesn't give any credit for public defense, defensive infrastructure, but relies on the building's mitigation measures. And as I mentioned before, IFC can randomly audit verifications at any time. So let me pause again here for any questions regarding the role of the verifier. Can you hear me? Any questions? You may be muted.
I see here one that says, you mentioned that BRI applies to compliant buildings. What is deemed as the standard of compliance across varying building codes internationally? I think that's a question.
Yes, I said that the building has to have met the local code. So whatever the local code is for that jurisdiction, that country, or that part of the country, BRI needs to get a rating above an NR, let's say, for that building to have met already the local code. In other words, they have to have a certificate of occupancy or whatever the equivalent document is for that jurisdiction.
Yes, and the next question, Eris, it says, can the BRI parameters be expanded, i.e. adapted, adjusted specific to a building typology, for example, healthcare infrastructure?
No, the mitigation measures essentially apply to all buildings. Obviously, the use of the building, may involve different, internal plumbing, internal electric circuits, internal, ventilation, and so forth. But BRI doesn't address, those. So, the building type is essentially is the same for all the BRI mitigation measures.
All right, and the next question says, how can we address projects that do not have locally registered verifiers?
Well, we're trying to get verifiers trained and certified in all the areas. So, obviously that's an issue. If we don't have a verifier in that location, we have to wait to get somebody verified. I mean, a verifier certified.
Aris, may I compliment? Please stay in touch with us. Let us know of a particular case. We are starting to have more verifiers in the world. We did not yet have a training for Latin America. Will come. But for instance, if we have one project, we can try to solve quickly the situation. We did that in India. A building owner brought 2 verifiers to us, and we trained them quickly. They passed the exam, etc. So until we get more verifiers on the ground, let us know. We can try to solve it on a case-by-case basis.
Yeah, we can do a pilot. We've done these pilot verifications where I have also been, providing some support to. But to do more than that, we definitely need to have the verifiers on the ground.
Yes, Eris, and thanks, Vanya, for that. Just to add on, in Africa, we currently have BRI verifiers in Mozambique, and this batch that we have for South Africa will be the second batch in South Africa. So currently in Africa, we have verifiers in Mozambique, and hoping that we'll expedite the process to get most of the participants to register and write the exam so that we can accredit them with as verifiers. Thank you. That was the last question. Eris, you can continue.
Okay, great. Thank you very much. So the third part of the presentation here is a case example. And I asked, the organizer said, can you suggest any buildings that we can use for our case example here? And one of the buildings was the Noma Hotel in Durham, South Africa. So, we don't have the definitive information, we don't have all the information, let's say, on the building itself, but I'm able through, public information and my own kind of, observance of maps and so forth to pull together, enough information to use for this case example and essentially raise the questions that the verifiers should be asking and should be checking. So here we have a hotel that was built, I believe it was completed and opened in 2018. It's 6 stories. It has 160 rooms. And and the question I had is, let me see if this building can be at the B+ level. That's a question basically I'm going to try to address here. And what information will I be looking at from the mitigation measures to, try to verify if this building is or is not at the B+ level. One of the first things I do, and obviously I would visit the site if I was there, but I like to look at the location. And if BRI has the complete hazard knowledge, it will tell me from the address what the applicable hazards are. Perhaps that knowledge for this location is not complete. And therefore, I will manually try to assess the hazards here. And one of the best sources of information, obviously, are public and on maps. So I look at this location. It's the red dot there in Durban, and it's about 600 meters, 0.6 kilometers from the coast there. The elevation itself is at 3 meters, the ground elevation. And I look at the kind of topography around that, and these numbers that you see there are relative to the site elevation. So +4 means 4 meters over the 3 meters, and 0 meters means at the same elevation, and so forth. So you see there along the beach, there's kind of like a natural berm. I don't know if it's natural or was man-made, but a little bit of a berm, and then you have that low area, and then the elevation kind of picks up as you go inland towards some of the hilly locations there. And I also look at older maps too. I sometimes pull a map, an old map, to see how that site looked, that area looked, 50 years ago or even earlier. And I look at flood histories, reports on floods, and basically I found that that area, that location was a former marshland. Older maps show that, and even today, in recent years, let's say that area floods frequently from storms. So you have storm surge and excessive rainfalls in that location, and I saw even pictures of some serious flooding in that part of Durham. So I know that water is an important hazard here. I also looked at the tsunami hazard, and I looked here at a map of oceanic, let's say, seismic activity, and Africa is surrounded by that, but the most active tend to be on the Indian Ocean side, not the Atlantic side. So, and there has been some seismic events there in recent decades on the Indian Ocean side. So I said that that maybe is a distance, if there is an event, probably a 3-4 hour distance for a tsunami wave to reach Durham. So I picked also tsunami as being one of the hazards. So when I looked at the hazards for this location, I said, okay, we have the default hazards. They always apply to every location, but flash flooding should be considered, and also tsunami should be considered. It didn't seem to be a very earthquake prone, that location. And also it kind of was further south from the cyclone prone areas that Mozambique, for example, we found there that the coastline of Mozambique is prone to cyclones, but Durban seemed to be much further away from the cyclone prone area. So I identified those as being the applicable hazards for the location. And then I was looking for, what is the key building information that I need to verify here, because I'm looking at the downburst, let's say, as being the dominant wind hazard. And the question I had, okay, the structure appeared to be reinforced concrete. That should satisfy even a much higher rating than a B. But are the windows rated for at least 160 kilometers an hour? So that's a question I would need to verify as a verifier. The building itself seems to have a lobby level, and then the occupied floors start above that, and there's at least 5, maybe 6 meters. So that first floor elevation is met. But given that this is a tsunami-prone location, I'm interested also where the mechanical electrical equipment is. And to be a B, that mechanical electrical equipment needs to be at an elevation of 5 meters. The ground is 3 meters, so it needs to be at least 2 meters above the ground. So I would need to check if I don't receive the information. I may receive some information before, but when I visit the site, I need to check the mechanical electrical equipment. Where is it? If it's on the roof, that's great. If it's on the ground floor, is it elevated? And how much? Then I would need to check the fire rating of the emergency doors. And that's for by the way, the green is for the A rating. The kind of yellowish here is for the B rating. So if this building hoped to be an A rating, it would have to be at least a 2-hour rating for the emergency doors. And if it aims to be an A rating rather than a B, it would need to have a sprinkler system. I didn't see sprinklers. They weren't evident from the photographs I had. So I need to verify whether there's a sprinkler system. And if there is a sprinkler system, what is the capacity of that system in liters per hour per square meter of the building? And BRI has a criteria for that. So is it over that or below that? So that's some of the key building information that I would be needing to verify as a verifier to determine. And we'll go through these tables that are in the user guide here, and I kind of highlight one by one. This is the wind table of mitigation measures. I highlight here in yellow what applies for downburst. I've just picked the downburst as being the hazard for this location. If it was in Mozambique and we had cyclones, there'd be a lot more yellow here. But looking at in yellow what is required for the B and the A. So for the B, for example, we need to have at least the structure being 130 kilometers an hour. It's a reinforced concrete structure, so we know it will do even at the AA level for BRI purposes. And then for the B, we need obviously that the building be steel reinforced. For A, you see there's a lot more requirements here. Those little Y's there indicate the requirements that are needed. So go through this and look at each one of these, and the bottom two, let's say, are the inspections that were done. The WD11 refers to the inspections that were done as required by the code. And to be a AA requires a second inspector to be inspecting the building, an independent inspector from the first one at critical points. If the building had that, to meet the AA, obviously we're not interested in that here. So let's move on to the water. That's the more challenging. And before that, let me explain something about water here, what we're talking about when we refer to these elevation numbers. The X is the elevation, let's say, from the water level, be it the sea or a river or a lake or even a dry creek that could flash flood. So the ground level is the X, the Y level is the first occupied floor, and we're looking at a 2-kilometer radius, what water bodies are within that distance, and obviously a flood can occur, and that's what we're wanting to mitigate for. So for the AA rating, and the red is for tsunami, the the level of Y, which is the first occupied floor, has to be 6 meters. For A has to be 5 meters, and for B 3 meters, and that is even higher for tsunami. And this hotel we've identified faces potential tsunami risk. So for the B level, it has to be the first occupied floor has to be at 5 meters, but also mechanical, electrical equipment have to be at the same. And another criteria here is that if the location is low in elevation, the water has to be able to flow through the bottom part of the structure, in that space where you see that little car there. If it's below 5 meters for that X, we want the water to be able to flow in and out where it floods. Because if the water builds up around the building will start acting like a boat and will try to lift itself. And that can potentially damage the foundation and damage the building itself. So if it is in a flood prone location where the ground is lower than the level required for the rating, even if the first occupied floor is higher, that lower level, we want it to be open to water coming in and out. And that can be achieved either through open walls or through closed walls with flood vents that open automatically when hydrostatic pressure builds up. And if it's urban flooding only, all this is just at the 3 meters level for the A. So there's a lot more, maybe this looks a little denser here. There's more measures, let's say, for the water mitigation measures. We're focused on the tsunami, but also the urban flooding, which is a default. And we see that, we need to satisfy this WTO9. I've highlighted in red because it's a question mark in my mind, is not just the first occupied floor, but the mechanical electrical equipment. Is that at least 5 meters above the sea, 2 meters above the land in this case here, to satisfy that tsunami? And is the roof sealed? Typically, a building built to code will have a sealed roof, so the code should be addressing that, but something to verify. And then we look at sealed openings, the windows and the doors, that rainwater doesn't get in and infiltrate the inferiors, and typically new construction built to code should satisfy that. Obviously, there are a lot more measures if we were aiming for the A level, that middle column there, that you would have to be checking, including the water resistance of materials, protecting from waterborne debris that can come with the water and damage the building, looking at the precipitation, the roof drains and on-site water retainage for different precipitation scenarios. And that precipitation data is typically available. If it's not in the code, it's available from the local meteorological association. So these are the water measures here. And then we go to the fire. Again, fire is a demanding category. There's here 2 pages, two pages of measures, and I've highlighted in yellow and that light red the measures that the verifier would have to pay attention to. In this case, for the B rating, we want to make sure that the structure is above half an hour. This is a reinforced concrete building, but so that is satisfied. We're not sure if we were trying for an A, what the rating is of the emergency doors and the exterior doors. So that would have to be checked. If it has eaves and vents and sofas, that they have fire resistant materials. And for an A rating, if it's a building above 4 stories, and this is, it's that it has a sprinkler system and that this capacity of the system is at least 0.25 liters per hour of water per square meters. And some additional fire measures. Again, looking at the B line here, emergency exit routes, that there are multiple exit routes. This building is open from all directions, so we assume that they have several exit routes. You would obviously check that, verify that. The electric circuit and wiring, most codes today are quite advanced in their electric, especially fire protection measures. So a typical code today, if it's a recent building, will satisfy that. In general, the codes tend to be the most advanced in fires and the least advanced in water. Even in developed countries, the water mitigation is not adequately addressed today in codes, and that's where BRI kind of, even if the building is built to code, may not satisfy the B level. And obviously, meeting the inspection criteria for the A and AA levels. And finally, in the geoseismic category, we'd be looking for, we're looking here just as subsidence. So we picked the subsidence measures that are shown in the Y. If it had seismic, there would be a lot more measures required. So we're focused on, has the foundation been designed to consider the site-specific soil conditions? So we need a statement from the design engineers that they have considered it. We're not going to do as verifiers any calculations ourselves, but if we sense any, changes of the level of the building when we visit the site, and that's why I like to carry my little level with me, we need to bring that up and say, there seems to be some tilting in this direction. Is the foundation good enough? And what do you plan to do to address it? Then we're looking for the resistance of the lateral forces. Again, verification from the design engineers, receiving the documentation and the steel reinforcement of the walls. And finally, for the A level, let's say we would need to have a design review according to building code. We're aiming for the B level here. So if the building has no vertical irregularities, meaning no part of the building is kind of sticking out, and this is a very geometric building in itself, that's a good pass for that measure. So my initial kind of, and this is unverified, my initial view of this building in this location is that for geoseismic and wind, it is probably an A, subject to verification. And in water and in fire, it is probably a B. The biggest question mark I have is in the water regarding the elevation of mechanical electrical equipment, whether it can satisfy that 5-meter elevation. So on an unverified level, my initial kind of, preliminary assessment is that this building is a B. And if I look at the operational continuity measures, I can easily see it satisfying number 8, multiple access entries to the site and the building. Obviously, you'll verify that on site. I'm not aware of any of the other measures, so those would have to be provided by the building and verified. What kind of backup it has for power, for communication, water supply. If it has a green certificate, I didn't see any green certificate posted for the building, but likely it will be able to meet perhaps another 2 of these and earn a B+ rating. But the conclusion of this example is how important the assessment and the verification is. And you see a picture of the building here, the elevation of the lobby, which is good. But verification is critical because without verification of the information, we cannot really know, the resilience and the rating of the building. So I conclude with that. Thank you for your patience, and I'm happy to continue with questions and any other topics you wish to discuss. Back to you, Petmo.
Thank you, Aris. Thank you. I'll just check if we still have any questions. I didn't see any other questions besides the one that Vanya just answered. Colleagues, if you've got any questions, we can open the floor. We still have about 5 minutes. and then we can attend to them. If not, we will share our email addresses, and then you can always send us emails.
And I will provide a PDF of this presentation that you can share with all the attendees.
Thank you, Aris. Thank you.
Thank you, Aris. And we plan also to post in our BRI YouTube. So if people want to go back, I heard we lost a couple of participants. They wrote back to us something didn't work for them. So it would be very useful that we will share all these materials. But feel free to ask questions now if you have. There is a question, when can we have updated hazard maps for India?
For India.
We are planning a release of new maps by the end of 5C's fiscal year, that is June 30th. And we hope that this is going to help, especially we will introduce more information about flooding. And yes, that's more or less the timeline. We acknowledge we are in a process that needs improvement, and we are trying to get there. As we mentioned, this is still a relatively new innovation of IC. We are not as EDGE yet. EDGE has more than 10 years of experience, data, etc. But we are doing our best to get there. Thank you for the question.
Thank you, Vanya and Ichama. You can go ahead.
Thank you, Petmore. I'm passing on for one of the participants. Can you just present yourself first and then?
Okay, my name is Neto Poldo, and I'm an architect, and I'm very pleased to be here. And as a professional, I think that this tool is very useful, but I see it as a huge challenge to apply here. That's why I would like to know from your side, what do you think about applying this tool in realities like our, where people are starving, we are facing the housing problems. There is a huge lack of housing here, and the projects that have been implemented, they are not fulfilling all the needs. And most of the measures that I saw there, they demand a huge investment. So it means that the construction will be much more expensive. So how do you see this tool applied here in realities like ours?
Yeah, that's a very good question, and one that has come up before, because a lot of the construction, typically, in the housing area, but even, not beyond that, is unplanned, has not gone through, code approval, or even if it has, it's, very elemental. And as I mentioned earlier, our goal is to try to avoid being NRs. And if you look at, you see a lot of measures there, but if you just isolate the measures for the B level, which is the level we are stressing, we try to achieve, it's a small subset. And one of the things that we came up with, and I think Vanya, this been going on for a while, is that there are buildings that will not be able to achieve these measures all at once, to go to a B level. Maybe they have some resources to address one mitigation measure or two this year, and maybe next year they address another one or two. So I think we kind of tried to develop also a B rating in progress. So a building that is an NR today, perhaps slowly can become a B. Some cases they may not be practical or even economic, but in the cases where it is, it can be a B in progress. So it says I have, let's say, 4 measures that I need to become a B. I'm an NR now. Maybe I can get resources to address 1 or 2 of these measures this year, and the 3rd measure next year, and maybe the 4th measure after that, and essentially step up to being a B level. The other thing to consider is that for a lot of these, the location is often a big determinant of the cost. In other words, if a location is a high-risk location, if a building is built on a floodplain or a former marsh or right on the coast, it is a lot more expensive to try to make it resilient, even as a B. If the land is already lower in risk, particularly the elevation of the land, I like to say, it's a lot less expensive. So, I think directing development away from high-risk locations is essential. In some cases, it will be too expensive to try to retrofit an existing building in a risky location, and the better choice may be essentially, to move to a safer location for the long term. So these are difficult but very important discussions to be having. But achieving the B level is possible even in less income, less resource rich, let's say, environments in developing countries. And that's really the focus we need to be at.
Thank you, Eris. I think we are running out of time. Colleagues, just to wrap up, I don't see any other questions. Just to wrap up, for the participants in South Africa, we will be reaching out to you soon. We will be conducting additional BRI cafes like what our colleagues in Mozambique have been doing, so that we can share insights on the BRI, especially for those who want to write the exams and are facing a bit of challenges. There's still quite a lot of information on YouTube. You could go on YouTube and also check on Building Resilience Index. And then a reminder, our colleague Vanya has put the links to the 2 mandatory modules, courses that you can take, the BRI measures and the fundamentals of BRI. Those are prerequisites before you can be able to write the final exam. I think with that, I will hand over to my colleague Itauma to give a vote of thanks and to close the session. Itauma, over to you.
Thank you, Petmore. I just wanted to request all the participants if they can take a few minutes just to give us feedback. I don't know if you can see my screen. I'm sharing the QR code and the link just to respond to this quick survey. This is a way of giving us feedback and help us improve, even to suggest subjects for the next gathering. Can you confirm, Petmore, that you can see the QR code? From here,
Yes,
we
we
are.
can see it.
If you have the link,
see.
would be great. Okay, Philippe just posted. It's easier for people who don't have the way to make a picture right now. Thank you all. Please answer this survey. It will help us a lot.
Thank you, Vanya.
I think we can conclude the webinar unless there's something else urgent. And as Petmore said, we remain available for your questions. So feel free. We are all learning through this process. So happy to receive comments, questions, critiques, suggestions. We are here to make this a real useful tool for emerging markets.
Yes, Vanya, maybe only to reassure the participants that we will be sharing this presentation and the links for the trainings that are available online. These are free trainings that you can take in your own pace. We will also share the link to the website where you can see the user's guide and everything else you would need if you want to become a BRI verifier or if you want to apply Builder Resilience Index in your own projects. From my side, I think it's all. I'm just going to ask if anyone else can give some comments here from the room. Se alguém quiser partilhar algum feedback, if anyone wants to share a feedback, please. I think Sylvia wants to close.
I think it's very interesting. Myself, I'm not an engineer, neither an architect, but I'm quite curious, interested in everything that is happening around improving housing conditions. So I think a couple of ideas that were here, although we might not necessarily become a verifier right now, those can be things that when we design our projects, we can take in consideration what is a good case practice and try to aim for that direction. But overall, I think I'm just going to subsidize what my colleague, the architect, mentioned. Like, given our reality, I think what was presented here is quite far from what Mozambique reality is. We are in a country that less than 5% have access to decent housing. And it's very ambitious, I would say, to now start discussing all the additional things that we need to lift the building 3 meters high. But of course, we need to start from somewhere. And the additional thing I would like to mention is when we say 10 years of experience, that's good in some sense, but most of the companies that are, let's say, entrepreneurs or emerging in the civil construction industry, they will have professionals like around 5 years experience, which allow you to have, I believe, the highest license to perform civil works. So if you aim at a professional that has 10 years experience, that's of course only for big companies. Most of the companies will not be able to afford professionals with 10 years experience unless they are shareholders. So that leaves a huge majority of players in that industry out of the, let's say, active participation as a verifiers. So if alternatives can be included, even if they're not verifiers, I don't know, can be other roles, or so they can be part of the system, part of the market, part of the process, I think that will be more than welcome, at least for Mozambique. Otherwise, this is just for big players that most of the times they are not even Mozambican companies, they're internationals. So that's my only comment.
Thank you, Sylvia. Vanya, I don't know if we still have time, if I can comment, or
I think yeah, you can go ahead and comment and then we can close it.
I just wanted to remind all the participants that we are open to collaborate with all in promoting Building Resilience Index program here in Mozambique. And there are a lot of roles that they can all play, because we all need to build more safely, to save time and to save money and to save not only lives, but also infrastructure. In terms of verifiers, it's just a responsibility of verifying well what was built and confirming that the building is indeed resilient. But all of us have some role in making sure that what we design and what we build are already with a great level of resilience. And one thing that Aries pointed out in this training is that local measures can also be factored here. We can have some solutions here in Mozambique that we can help the Building Resilience Index team consider further in the software. This is a work in progress, and we wish people like you, Sylvia, could join us and help us promote this in Mozambique, because we need to build more safely. We agreed on that. Thank you.
Happy.
Thank you. I think without further, we can close the session. Thank you to all the participants. Thank you for the time. We know you've got busy schedules, but you did manage to secure time to be with us today. We hope to be reaching out to you in the near future with more information on BRI and to assist everyone who wants to be part of the BRI family. Thank you.
Thank you.
Thank you, Eric.
Alice.
Bye-bye.
Thank you, Petmo. Bye.
Thank you, everybody.
Obrigada a todos. Ciao.
Bye-bye.